I atlased in view for several hours and did something that doesn't usually make the news. It wasn't photographing a pretty comet. It was checking where exactly it was heading next and whether its actual path matched what we expected back in late December. And here's what we discovered. 3i Atlas hasn't slowed down, broken up, or gotten lost. It continues to move away from the inner solar system at a high, virtually constant speed. So, this isn't a story about the object passing by Earth and disappearing. It's a story about it moving along a trajectory that will see other planets appear on the horizon. And that's a completely different story because it could then encounter Venus, pass close to Mars, and enter a zone where its motion will become heavily dependent on Jupiter. The most important thing Hubble saw in its calculations sounds very simple. If we continue tracking the comet at its current speed and direction, it will most likely leave the solar system. Not someday, but precisely because of its trajectory. It's not a circle around the sun, not a loop with a return, but a departure outward to a place where there's no second chance to fly close again, just like that. But there's a nuance that has observers on edge. Judging by its current path, it's not flying straight into the void. It's traveling in a way that brings planets into view, and each encounter can subtly alter the future. In space, this works without any mysticism. Even if an object doesn't activate any thrusters, a close flyby of a planet can alter its trajectory. And if the object is also capable of correcting its motion, then these flybys become not random, but convenient points for maneuvering. The first potential encounter along the new trajectory is Venus. Not a collision, not a catastrophe, but a flyby. Roughly speaking, if the comet maintains its current course, it could be near Venus's orbit as early as the end of January. And this is where the most challenging observational situations begin. Venus often produces poor geometry, light pollution, and awkward angles. This means the object could pass through a location that's difficult to properly capture with optics, especially if it chooses a moment when it's most difficult to observe. Further on, there's a possible section where it crosses the orbit of Mercury. This is closer to the Sun and less favorable for telescopes due to the background, light. This is precisely the corridor where any small changes in velocity can be hidden because there's noise and light pollution all around, and people have less confidence in the purity of the data. Therefore, Hubble isn't just looking at the object now, it's trying to predict whether there will be anything there that will change the forecast. The next logical milestone along the way is Mars. If the trajectory maintains, the intersection of Mars's orbital zone will occur around the end of February or the beginning of March. Again, not a collision, but a flyby corridor. But Mars is important not as a risk, but as a marker. If the comet passes there along the expected line, this will confirm that it is indeed moving outward and not making a hidden turn. And now comes the most important part of the whole story, Jupiter. Because Jupiter isn't just a planet, it's a huge trajectory switch. It can eject an object completely, or it can alter its path so that years later it will re-enter a convenient plane and we'll see it again. And that's why the question of has it left the solar system is actually twofold, but easily explained. It hasn't left yet, it's only just leaving. But its final outcome will become clear once its future begins to depend on the larger planets. Now about the collision, so as not to leave a hole. Based on its current trajectory, a direct collision with Venus, Mercury, or Mars is not predicted. But this is a prediction that works for a passive body. If 3 Atlas is capable of even slightly changing course, then not predicted ceases to be a cast iron phrase. Then the danger isn't that it will crash tomorrow, but that it could turn a safe flyby into a dangerous one without much preparation. And this is the main fear of observers. They need to understand whether they are looking at a rock or an object that can adapt. And then, during the same period that Hubble was tracking the comet, it noticed something else. A new object appeared in the same observation zone, faint but distinct. It was initially mistaken for noise, then for a regular comet, but it quickly showed signs of a more dangerous geometry. It was approaching too close to the sun. A close pass near the sun carries the risk of disintegration. Disintegration creates a trail of particles that can then cross orbits and cause problems for satellites, communications, and even the upper atmosphere. This new comet becomes a secondary plot point to the first, and here's why it heightens the tension. While everyone is watching 3i Atlas and trying to figure out where it's headed, another object appears near the sun. One that could wreak havoc not with its impact, but with its consequences. And if the two events overlap, observers become overwhelmed, telescopes split their schedules, data is published later, and the noise in the information field becomes the perfect cover for any Atlas anomaly. And at the end of this section, we return to the main point. Hubble didn't say it disappears. Hubble actually showed the comet is moving away and moving along a path where it will encounter planets. Venus, then the inner orbital zones, then Mars, then the prospect of Jupiter as a decisive junction. And if this is an ordinary body, we'll see beautiful mechanics. If this is not an ordinary body, we'll see how it exploits these points to its advantage. Let's quickly clarify what Hubble saw and why it's not just another trajectory in the table. When an object leaves the inner solar system, its path usually begins to blur due to small factors: solar radiation pressure, jet streams, measurement inaccuracies, and even noise. But based on the latest series of data points collected by Hubble, the picture is too smooth. Not perfect, but smooth, as if the object is maintaining a consistent pattern. Its velocity is almost constant, and its path appears stable, without any chaotic deviations. This immediately answers the question of, has it left the solar system? No. Right now it's still within the system, still under the influence of the sun. But the type of trajectory is already clear. It's an exit, not a return. And here's an important clarification in simple terms. Leaving the solar system means accelerating to such a speed that the sun's gravity can no longer bring the object back. This is called a runaway trajectory, and from what Hubble is currently seeing, the comet is close to exactly this scenario. Unless there is a strong impact from a large planet, it will leave for good. Now about the planets, what he will meet, and what this gives to the plot. Venus. While we had the closest approach to Earth story at the end of December, Venus is now becoming the first major point where an object might behave in a way that makes it more difficult to observe. Why is Venus a convenient cover? Because the observation geometry is often poor. The brightness of Venus itself, its proximity to the sun and the sky, light pollution, and small angles. On paper, this looks boring, but in reality, it means one thing. The object might pass through a region where official images will be rare, dirty, and subject to many caveats. If you need to do something and keep a low profile, this is one of the most convenient places. And here comes the first alarming moment. If a comet really can make even the slightest course correction, then Venus isn't just a planet in its path. It's an opportunity to slightly adjust the trajectory and make the next leg of the route more favorable. It doesn't necessarily have to be a sharp turn. Sometimes a tiny adjustment is enough for the course to change by millions of kilometers within a month. Mercury. The inner corridor near Mercury's orbit is always a disadvantage for observers. Everything is hot there. The solar background, limitations on telescope pointing, less time for long exposures, and a higher chance of missing a faint object. Therefore, Mercury is important in this scenario not so much because it will see the planet, but as a place to hide something strange. If, after Venus, the object experiences a micro shift in velocity or the direction of its jets changes in a way that affects its trajectory, it is in this corridor that the anomaly could disappear into the noise. Mars. Mars, on the other hand, is convenient as a reference point. It's less subject to light pollution, less of a nightmare at the corners, and it's good because it's easy to compare models. If the comet passes through Mars' corridor exactly as calculated, this confirms inertial drift. If it passes differently and the deviation is systematic rather than random, then it's no longer a matter of it seems so, or the instrument was wrong. Then the question arises, What exactly pushed it? And now, the main thing is Jupiter. In such a story, Jupiter is the switch that divides the plot into two different future worlds. The first option is boring, natural. Atlas passes far away without any serious interaction and simply disappears. Then we'll have a rare object that puts on a show once, and that's it. The second option is scary, smart. Atlas is performed in such a way that it receives a significant gravitational correction. Then two opposite things are possible. Jupiter finally ejects it from the system faster and more reliably. Jupiter does not eject it, but rather adjusts its trajectory so that the comet enters a convenient plane, and after years will again become visible and dangerously close. And it's precisely this second option that makes the question, will we see it again, come to life. Because again isn't tomorrow, it's years away. But if the object returns along the correct plane, then it becomes not a coincidence, but a repetition. Now, there's an important thing that Hubble could have noticed right now, even without waiting for Jupiter. It's the geometry of the escape. If the line isn't simply outward, but outward so that it intersects the orbital planes at convenient locations, it begins to look like a route. And that's what you asked for, not mysticism, but the sense that the object is choosing corridors. Now about the collision again, but this time in the logic of what if it is controlled? With a passive body, everything is simple. A collision with a planet is extremely unlikely, and all calculations confirm this. With a controlled object, it's different. A collision as a goal seems pointless, but a hazardous flyby can be part of the mission. What is a hazardous flyby? It's when an object passes close enough to impact the environment around it, gravitationally, plasmatically, electromagnetically, through emissions. It doesn't have to hit a planet to cause problems. It's enough to pass close enough to trigger conditions that we later perceive as strange coincidences, glitches, surges, strange failures. And here we return to the second plot line, that same, more dangerous comet that Hubble noticed during its observations. Imagine a simple fact. Telescopes are looking where Atlas should be, and suddenly, in the same field, in the same time window, another object appears, heading toward the sun on a risky trajectory. This automatically creates two effects. The first effect, competition for attention and resources, telescope time, data processing, priorities, schedules. Even at the human level, some of the team will switch to the new threat because an object near the sun could become a problem faster than the departing Atlas. The second effect, the perfect cover. While the public, the media, and even some of the scientific community are focusing on the new comet, any odd bit of the comet's behavior can be easily swept under the rug by the phrase, data is being updated. And here's why this new comet may be more dangerous precisely here and now. A comet passing close to the sun can sharply increase activity and become bright but unstable, begin to disintegrate and leave a dense trail of particles, produce powerful emissions that then turn into a trash trail in orbit, create conditions for a beautiful but very bad coincidence when the Earth then crosses this trail. And now that we have two lines, we focus on the comet again, but with a new anomaly, as you requested. The new anomaly shouldn't be another jet, and I agree. It makes sense to have an anomaly about speed and planned maneuvers. That is, not it seems, but it's visible in the numbers. Because if Hubble and the ground-based observation network provide a trajectory, the simplest indicator of controllability isn't the shape, the tail, or the pretty shots. It's a small but consistent deviation from the calculation. Subtle, almost imperceptible to the viewer, but devastating to specialists. When the model predicts one thing, but the object stubbornly ends up in a slightly different place week after week. This isn't called an error, it's called non-gravitational acceleration. Comets have this, but it's more chaotic and depends on heating. But here, it can appear smooth, as if someone is maintaining a constant controlled motion, and it's at this point that the story becomes simple and alarming. Hubble confirmed the departure of 3I Atlas, its route through the planetary zones, and simultaneously spotted another object near the Sun. And then the question isn't, what is it, but what will happen first? Will 3I Atlas manage to hide in an awkward geometry near Venus? Or will a new comet near the Sun trigger an event that will distract everyone so much that we miss the key maneuver? On January 9th, Hubble delivered what everyone who can read orbits, not headlines, had been waiting for. The Atlas departure path became stable, and most importantly, it no longer looked like a random object that just popped in and out. That same day, JPL puts together a quick debriefing, sans press releases or fancy words. One thing is on display. The next month is shaping up as if the object is deliberately choosing the areas that are most difficult to view. On the surface, it's presented as routine, updating the ephemeris, a new observation arc. Inside, it sounds different. If he moves again now, we'll know not from the photo, but from the aftermath. The key point is simply called Venus. Not because it's more important than Earth, but because near Venus it's easy to lose control of observation, and it's all too convenient to hide anything you don't want in the frame. The problem isn't that Venus is bright, it's geometry. On certain days, the object appears in the sky where large telescopes are either limited in their aiming, caught in light pollution, or have short viewing windows. And here's where things get unpleasant. When a trajectory by itself leads an object to a place where the world is less visible, it's still a coincidence. When this happens repeatedly, it becomes a behavior pattern. NASA is holding a closed-door meeting with ESA and several major observatories. Formally, they're discussing observing windows. In reality, they're discussing how to avoid losing the object at its most opportune moment. That same night, ground-based telescopes began to show a strange brightness pattern. It wasn't as if the comet had dimmed, but as if it had switched on a mode. The brightness would drop for an hour, then return and repeat several times. A regular comet can do this too. They'll tell you. Yes, but it's usually due to rotation and heating. This is a different kind of coincidence. Dips in brightness coincide with moments when the object moves to awkward viewing angles. Radio lines come into play, not as a secret radar, but as a simple test. If the optics are obstructed by angles, you can view indirectly. And here comes the second layer of concern. A weak but repeatable delay appears in the radio propagation data transmitted through various stations. It's not global, not a solar storm, but rather narrow, like a line, as if someone is tweaking the environment along a specific geometry. Externally, this is attributed to the ionosphere. Internally, the question is different. Why does this ionosphere flare up precisely when the Earth and the object are aligned? And why is the flare localized and not planetary? Another thing is coming to light that's difficult to explain to the public without causing panic. Several satellite operators are reporting brief channel dips along the same arc, as if someone were walking along the beam. It didn't cut the internet. It was brief, precise, and unpleasant. Exactly what a test looks like. Not a shock, not a catastrophe, but a test of what the system reacts to and how quickly people notice. That same day, someone raises a question that people usually try to keep quiet. If a comet can maintain a regimen, then it can choose not only where to be, but also when to be visible. Hubble is again producing a series of dots, and something appears there that breaks the calm, going outward scenario. The speed remains almost the same, but the direction changes by fractions, and this change doesn't look like noise. This isn't a 90-degree turn or a turn back. It's a small adjustment, so small that it's nothing to the onlooker, but to a ballistician, it's a red flag. That's what a controlled correction looks like, and here's where the conversation about planets begins, without the romanticism. If the object maintains its course, it won't encounter planets like a tourist. It will pass through corridors where the planets become anchors for the rest of the route. Venus is the first support. Mercury is a screen behind which details can be hidden. Mars is a control point where it's easier to detect divergences. Jupiter is the switch that will decide whether an object will disappear forever or return years later. On January 10th, they face a risk scenario. The object passes in such a way that the moon obscures some of the observations, and the Earth becomes more contrasting against the background. Not mystically, but purely geometrically, easier to photograph, easier to measure. That same evening, they notice another disturbing pattern. The jets, which had previously seemed chaotic, begin to count steps. Not artistically, but by angles. The discharge shifts by equal degrees. If it's a comet, that's strange. If it's an orientation system, it looks like a grid, as if the object isn't ejecting something from overheating, but drawing a grid, marking the space around it. And it's precisely against this backdrop of routine that Hubble throws up a new plot. While it's keeping the comet in frame, another faint object is in the same sector, moving much more aggressively toward the sun. This isn't a second comet for show. This is an object whose trajectory toward perihelion is such that it could sharply intensify and disintegrate. And if it disintegrates, the trail it leaves behind could become more dangerous than the object itself. NASA doesn't say a more dangerous comet, they say something else. We need to evaluate the dust contribution and the probability of Earth orbital collisions. In layman's terms, this means a layer could form that the Earth could touch. The discussion includes spacecraft already in space, which makes the story more compelling. Parker Solar Probe and Solar Orbiter provide context on the solar wind to distinguish storm from external impact. Next, they connect everything orbiting Venus and Mars, because if an object is passing close to Venus, any device in orbit around Venus will be a witness, even if no one was planning to observe it. And here's the scary thing. When you build a picture based solely on telescopes, you can argue about noise. When you see coincidences across different types of sensors, the argument turns into a question of who's doing this and why. The first public crack appears. One private astronomy project publishes raw light curves and reports that the behavior is unusual. No sensationalism, just the facts. A couple of hours later, the post disappears. Officially, it's a processing error. Unofficially, people see that the do not disturb until further notice request has worked. It's like smoke without fire. No one admits it, but everyone understands. There are two camps within the team. The first says, don't push it until we've tested it. The second says, if it's manageable, then the latency is what's working against us, because the window is short and the target won't wait. They set themselves a simple test that doesn't require any imagination. If it's natural, the deviations will be jagged and dependent on heat. If it's controlled, the deviation will be smooth and repeatable. And at that moment, the comet does something that, in terms of numbers, looks like a joke. For several hours, it maintains a nearly constant deviation, as if it had locked its course and decided not to let go. It's not twice as fast. It's a slight boost, a slight adjustment, but it coincides with that same unpleasant window where the optics get blinded by the corners and you have to check through indirect channels. And here's where the scenario becomes clear to any viewer. No lecture required. He doesn't just fly. He chooses the moment when he's least visible, and that's when he does something that changes his future route. The only question now is, where does it go after Venus? And here Hubble provides the answer, not in words, but with a line on the map. The next corridor stretches to where, in months, it will be easiest to hide in the solar glare. They calculate time roughly, without drama. At its current speed, the object won't meet the planets tomorrow. It will pass through key nodes when public interest has already faded, and attention is shifted to a new comet near the sun. And it's a near-perfect combination. The new comet will provide spectacular images, headlines, and discussions. The comet will have the quiet time to calmly complete its maneuver and move away to a place where it will be difficult to catch again. The most vexing question is, will we ever see him again? If he simply departs on an escaping trajectory, then no, the window will close forever. If he uses gravity assists, then one more time is possible. And once again, in this case, won't be a random gift to astronomers. It will be a return along the corridor he's prepared for himself, with a plan, with geometry, with a repetition of the conditions. At this point, a line appears in the private notes that no one will say out loud. If an object can adjust, it can choose not only its route but also its audience. In other words, who to show and who not. Hubble is once again taking the comet into the window everyone had labeled as the last sensible chance, before Venusian geometry. And the key point is immediately apparent in these frames. The object no longer behaves like a body simply drifting outward. It maintains just enough brightness to be manageable, but not so much that anyone accidentally overexposes details on the widescreen, and this feels less like the physics of dust than like a precise, disciplined behavior. On the same day, a new connection appears in the calculations. The trajectory after Venus is such that it looks nice on paper, but in reality it means one thing. Most of the best observatories will see it at poor angles. When this line is superimposed on a telescope accessibility map, it's almost a mockery. The southern hemisphere sees short and low. The northern hemisphere is hampered by light pollution, and space-based instruments are limited in their pointing capabilities. NASA maintains a calm tone publicly. They say, the geometry is complex, but we're monitoring it. Internally, the conversation is different. If it wants to disappear, this will be the right moment. The first shock to the nerves arrives, and it's not about the footage. Several stations are recording a similar, brief dip in star tracking accuracy across different satellites, as if a single pulse had passed through them. It's not global, not a sun flare. It's a flare that occurs along an arc that coincides with the Earth Atlas line at the hour the object enters the Venusian sector. Then comes the always ugly part, the words, "not to be published until further clarification." Not because they're hiding something, but because one false explanation would destroy trust and the correct explanation isn't available yet. The object is doing what it seems to have been pulling everyone toward Venus for. It produces a short, sharp jump in the behavior of the jets, but not in brightness. The camera sees almost the same thing, but the orbit hears as something else. It looks like a small maneuver that dissolves in the optics, but remains in the dynamics, and that's precisely the most dangerous thing. Change occurs where most people don't know how to argue. That same evening, an unpleasant possibility pops up in the calculations. No collision with the planet tomorrow, but a corridor of close encounters appears, where a small maneuver today can change the outcome months from now. That's exactly how gravity games work. You move a millimeter now, and then you get kilometers at the desired point. And if an object does this confidently, it's not a random visitor, it's a player. For the first time, they seriously mention Jupiter. Not as someday far away, but as this is the node that will decide whether we'll see it again. If it passes through Jupiter, the chances of its return drop. But if it follows a trajectory where Jupiter becomes a slingshot, that opens up a different scenario. A return is possible years from now, at a different window, along a different line, when we'll no longer be waiting and watching. And against this backdrop, while everyone is staring at the comet, Hubble makes a discovery that's initially unwelcome. In the same footage, another object is detected, faint but with a trajectory toward the sun that's too straightforward. It's not impressive as a pretty tail in the sky. It's dangerous because it's moving quickly toward perihelion, and such bodies tend to disintegrate, leaving a dust knife that then intersects Earth's orbit. The ESA is using its dust flow models, and a strict formulation emerges. If the decay occurs at a certain location, the probability of a thin layer intersecting with Earth is non-zero. This isn't a catastrophe yet. It's a sticky trail scenario where after weeks or months, the Earth catches a thin trail and suddenly cameras around the world pick up unusual fireballs. That's why there's a strange feeling in the room, as if the comet were just a distraction. While everyone's attention is focused on it, a risk appears nearby, easier to miss because it's visually duller. NASA is doing something that looks like bureaucracy but is actually anxiety. They're shifting observation priorities. opening up windows for a new comet near the sun because things get decided quickly there. It's a tricky dilemma. If you only look at 3ATLAS, you might miss the real dust trail. If you switch to the new comet, you're giving 3ATLAS what it needs most. Another thing is coming up, something that's usually not talked about loudly because it sounds too simple. Space weather stations detect localized bursts in the ionosphere along a line that coincides with the Earth Atlas geometry. Not storms everywhere. Not the magnetic field is going crazy. A narrow line, a short window, repeatability. It's like a test, how the planet reacts, where the weak points are, where they'll be noticed faster. To explain it to the viewer in layman's terms, the scene goes like this. Someone is passing by, testing what happens if the upper atmosphere is slightly disturbed, but in such a way that it appears to be a rare freak of nature. The object enters the Venusian sector and the cover-up begins in earnest. The best optics detect flare and short windows, and the public receives the dry phrase, "Observations continue." At this hour, people aren't looking at pretty photos, but at indirect signs. Communication stability, targeting accuracy, strange channel gaps, and timing coincidences between independent stations. And it's at this moment that a new anomaly emerges, one that no one wants to call cloaking, but it's not noticeable otherwise. Several major observatories simultaneously publish images where the background is present, the stars are there, but the object is missing. It's not mist, it's not clouds. It's a series of empty frames, during the same 18-minute interval when the geometry should have been the best possible in this configuration. When they compile their reports a day later, it turns out that the object seems to have removed itself from the image, leaving everything else untouched. And this isn't about science anymore, it's about control over what we can record. Hubble returns from another limited observation period and provides dry telemetry. There, just before the problem window, the same sequence of micro-glitches repeats, just like last time. 2 coincidences can still be chalked up to luck. 3 coincidences turns it into a pattern. And if the pattern is linked to the appearance of an object in a specific geometry, then the connection is not random. A new comet near the sun begins to exhibit aggressive brightness. Its curve fluctuates, like that of a body heating unevenly and preparing to disintegrate. This means dust can appear quickly and in large quantities. And now, NASA is forced to manage 2 stories simultaneously. On the one hand, there's Atlas, which is taking awkward angles and making small but precise course corrections. On the other, there's a new comet that could leave a sticky trail. At this point, the worst-case scenario of the week arises. If the new comet disintegrates, and if Earth subsequently crosses the thin layer, people will see not a beautiful shower in the sky, but strange, violent fireballs all over the world. And against this backdrop, any subsequent Atlas maneuver will become not just an anomaly in space, but a factor that reinforces the feeling that someone is testing not only the sky, but also the reaction of civilization. Hubble is finally delivering what this whole circus was all about. The comet's new trajectory fits the calculations as if the object had stopped wandering and chosen a route. Not just in words, in numbers. It does indeed move outward, but not as a body pushed by the sun. It follows a line where each major planet becomes a gateway. Venus, then the inner corridor, then the node, where Earth no longer decides. The most frustrating thing about these calculations is that they don't show chaos. They show discipline. A fraction of a degree of error would send the track careening off course, but the line holds as if it's being held. According to new data, the coming weeks will be a Venusian shadow. The object passes through the sector so quickly that optics only catch it in fragments, leaving a full window only for those skilled in working in bright light. NASA doesn't write a press release on this day. They're conducting an internal review, which telescopes to place where, which stations to turn on, which windows to protect against failure. It's more like preparing for a mission launch than for a comet observation. The calculations then turn to a list of nodes, and it sounds simple, almost too simple. Venus, then a return to the inner orbits, then a corridor to Mars, and then it's all up to one giant, Jupiter. It will be the final door. If Atlas approaches it with just the right geometry, the slingshot will eject the object so we'll never see it again. Or we'll see it years later, but it'll be too late. Why or? Because at a different angle, Jupiter could do the opposite. It might not eject it, but rather adjust its orbit so that the object returns when no one is waiting and no one is watching. That's what's scary. The trajectory itself isn't scary. What's scary is that it resembles a schedule, as if someone is choosing the nodes in advance to achieve the desired effect every time. The question of a planetary collision is practically closed on paper. The probability of a direct hit is negligible, and that's fair. But the danger here isn't the collision. The danger is that the maneuver changes the rules of the game. If an object is capable of making small adjustments, it can intentionally move where it's difficult to observe and appear where it wants to be seen. This isn't a threat of falling over, it's attentional control. Hubble reveals a second detail. The velocity after the Venusian sector drops differently than it should for a passive body in this profile. The difference is small, but it's stable and repeatable across different resolutions. Translated into normal language, it seems to slow down where it's convenient and speed up where it's advantageous. These aren't jerks that appear on camera. These are adjustments that are only visible in orbital remnants. That same day, a word that's not widely spoken appears in the protocols, re-emergence window. This doesn't mean we'll return tomorrow. It means the trajectory allows for a return in a few years. If the object escapes through the corridor blocked by Jupiter, we'll lose it. If it escapes through a corridor that leaves a chance of interception, it could re-enter the inner system, and it becomes a matter of choice. And here's where something important for the viewer to hear, without the fancy jargon, comes in. We're used to thinking of space as a roll of the dice. Here the feeling is different. It's as if the dice are being rolled, but someone is choosing how they fall. On January 26th, Hubble switches part of its time to a new comet near the Sun, and it's at this point that it becomes clear why NASA is so abruptly twitching. The new comet's light curve is oscillating, unlike that of a calm nucleus. It looks like heating in cracks. It's as if there are pockets inside that are opening up in layers. Such bodies tend to break apart as they approach perihelion, turning into a streak of dust rather than a beautiful tail. The ESA offers a blunt prediction. If the decay occurs within a certain range, Earth could be exposed to a very thin layer of ejecta within a few weeks. It's not the end of the world, but the chance of a meteor shower becomes real, and this is precisely the type of event that frightens the masses, not because it's destructive, but because it occurs synchronously, overnight, all over the world, and feels like a signal, not like cosmic weather. A simple thing is happening in the room. Someone asks, what if these aren't two independent events? What if Atlas and the new comet are connected? What if the former is just something we're looking at, and the latter is something that's actually changing the environment around Earth? It sounds crazy until you remember the timing. As soon as Atlas enters an awkward geometry, a new object appears, forcing resources to be diverted, and someone cleverly buys time. On this day, strange bursts of light appear again in the upper atmosphere, not across the entire planet, but in a narrow arc, and again, at times when the Earth-Atlas line coincides with a specific sector. If you explain this to the viewer honestly and simply, it feels like a test. It's as if someone is watching how our sky, communications, and navigation react, and how long it takes us to notice a repeat. Atlas is once again introducing a new quirk that irritates engineers the most. It doesn't disappear completely, it's not just for show. It makes everything look almost normal, but it always leaves a mark in the residue. And this is precisely what breaks conventional thinking. Nature usually creates beautifully and chaotically. But here, everything is neat and economical. Not an ounce of unnecessary brightness. Not a single extra minute where unnecessary data could be obtained. By evening, NASA makes a decision that won't be announced outright. They're redistributing satellite slots so that some instruments operate atmospherically and others in orbit. They want to understand the cause and effect relationship. Because if the meteor shower from the new comet really exists, and if 3 ATLAS continues to test the upper atmosphere, a chain reaction could begin. And it can't be waited out by silence. Hubble's planetary forecasts are now less poetic. Mars is in the closest line, a possible point for a distant pass. Not tomorrow, not a crash, but a node where gravity will adjust the trajectory. Then comes the zone where one question decides everything. Will Jupiter be an ejection or a reversal for it? It will be clear there whether we'll ever see it again or whether it's gone forever. And at this point, a phrase no one likes to say out loud, but which rings true, appears. He hasn't left the solar system yet. He simply chose a route that will allow him to exit later and in a different way. If this were a comet, things would be simpler. It would degrade, disintegrate, lose activity. But here, activity doesn't disintegrate. It changes modes, as if to suit a task. A new comet near the sun begins to accelerate its brightness increase. This is the moment when comets either open up or break apart. A window appears in forecasts a very short time before the point of maximum heating. NASA and ESA aren't arguing about whether it's dangerous in general, but whether it's dangerous to us because of the dust. Because dust isn't an impact, it's thousands of re-entries, failures, false alarms, and system overloads. And this is the kind of pressure that could coincide with any new Atlas anomaly. Your services are overheated, your skies are noisy, everyone's looking in the wrong direction, and that's precisely the moment to make your next move. Hubble returns to 3 Atlas again and pinpoints the key. Another small maneuver, too precise to be a random ejection. And this means one thing: the trajectory remains active. Not we calculated and forgot, but we calculate and it changes. And the further it is from Earth, the less likely we are to catch it quickly. Because the signal is weaker and the windows are worse. Hubble doesn't produce a photo or a pretty picture. It produces a table. And in that table, there's a line that makes everyone's hands go cold. Return window. This doesn't mean Atlas will turn around tomorrow and head back. It means something else. Its current trajectory allows for the possibility that in a few years it will cross the inner solar system again and along a geometry that can be chosen in advance. The meaning of the window is simple. If a body departs purely along a hyperbola, it disappears forever. If it departs through gravitational nodes so that its velocity afterward remains within a narrow range, a chance for a return visit arises. And that's where Jupiter comes into play, not as a major planet, but as a switch. A little closer to it, and you're ejected from the system. A little further, and you get an adjustment that keeps you close. In normal astronomy, this is called luck and dynamics. In this story, it sounds different, like mode selection, because Atlas has almost gotten it right too many times. Hubble draws 2 corridors. The first is short and harsh, permanent departure. The second is longer, dirtier, and more unpleasant, delayed return. And both corridors pass through places where observations are inconvenient. The second corridor isn't more frightening because it's physically more dangerous. It's more frightening psychologically, because if the target knows how to leave in a way that allows them to return, they also know how to wait for us to relax. At this point, NASA is doing something they'll never reveal publicly. They're starting to recalculate not only the object's orbit, but also the orbits of our reactions. Who will be on shift? Where the telescopes will be? What will be considered a malfunction? Because the return window on paper is just math. But in reality, the return window is people's habit of not believing until it's too late. And that's the weakest part of the entire system. They run a series of calculations on Jupiter, changing the parameter at the centimeter per second level, and each time they get a different fate. Flew away, returned, passed below the plane, ascended higher. At one point, one of the engineers utters a simple phrase. If he can give himself even the slightest adjustment, he can choose the corridor. The room becomes very quiet, because a small adjustment in space isn't a small thing. It's crucial. With it, you're not a passenger. With it, you're a pilot. And this brings everyone back to the one thought they're afraid to say out loud. On the same day, a new comet near the sun reaches a stage where its behavior ceases to be aesthetic. It begins to rain. Not beautifully, not like a postcard-worthy tale, but a dirty ribbon of fine particles. The ESA notes that the spectrum changes abruptly, as if the core were opening pockets. This is a scenario where we don't expect an explosion. We expect a thin layer of dust, which will then settle into orbit like a film. And then the term sticky trail appears. It sounds funny until you understand the mechanics. A thin layer of emissions may not dissipate immediately. It may remain in the path that Earth will later follow. A window appears in the forecast. 12 to 24 hours after a certain dust discharge, the Earth crosses the edge of the layer. And this isn't a massive meteor shower. Rather, it's hundreds of smaller inlets, observed by cameras around the world. Such events aren't dangerous because of the fire. They're dangerous because of the noise. False alarms, observation overload, satellite forecast glitches, and leaps in risk assessments. The perfect environment for someone to hide the real action. That's why NASA is switching back to ATLAS. Because if the two windows align, if the atmospheric noise spreads around the world, the object will have a chance to do what it loves, pass in the shadows. At night, they experience something strange. Not a major maneuver, not a jet show, but a minor geometry. The object reorients itself so that its phase curve becomes flat. Simply put, it stops playing with light like a normal body. It becomes more difficult for optics to detect at precisely the moment when, according to the schedule, it should be better. And this seems too clever. Officially, this can be called a dust coma in rotation. Unofficially, it looks like a cloaking mode. Not invisibility, but a shift in contrast, where no standard algorithms can detect it. And here a new anomaly emerges, one that previously seemed pointless to discuss. Several independent observations have detected a faint double signature near the core. It's too close to be a star. It doesn't always appear. It appears at specific angles. It's as if there's a structure next to the object that only produces reflection at a certain orientation, like an edge or a panel. NASA is trying to rule this out as a processing artifact, but the coincidences refute the explanation. Different cameras, different locations, different conditions, yet the microtrace appears in the same relative position. This isn't proof of anything. This isn't the final truth. It's worse. This is bait for suspicion that can't be discarded because it crept into the data so neatly and quietly. Meanwhile, a new comet near the sun produces its first real dust emission. Services begin preparing for a flurry of minor encounters. And it is precisely during the same period that Atlas is once again free, because people's attention spans are finite. While fireballs are detected on Earth, it's easier to conceal subtle trajectory adjustments in space, and if the object understands this, it acts accordingly. In the morning, a calculation emerges that changes the emotional picture. One of the corridors to Jupiter offers neither a departure nor a return. It offers a third option, a loop where the object can re-enter but from a different angle. This means that if it so chooses, it can select new planets for encounters. Mars, then the asteroid belt, then the giants. And each node is a chance to change speed without explicit propulsion. The thorny question of a collision also arises. A direct impact on the planet is still unlikely. But another possibility arises. Close encounters with planetary moons and large asteroids in the belt, because a collision is unnecessary. It's enough to pass close enough to pick up material, change the shell, and shed excess. To humans, this sounds like science fiction. To mathematicians, it's simply an acceptable maneuver. On the same day, Hubble notices Atlas noticed another small detail. The repetition rate of the faint flashes in the tail becomes even, like a metronome. Not bright, but stable, and it looks like a pattern again. To put it simply, it's like a diagnostic. Turned on, checked, turned off, changed orientation, repeated. Not for show, for control, because chaos doesn't repeat itself. By evening, the sticky trail begins to work. Cameras around the world are picking up unusual fireballs, short, sharp, often with unusual fragmentation. NASA says it's natural, but the timing is too precise. And against this background of noise, Atlas does something that will be replayed frame by frame for weeks. It loses part of its coma for a few minutes. It doesn't completely disappear, but it looks as if its shell has thinned. For a comet, this could have been a flash and disintegration. But here there is no disintegration. There is a neat transition. It's as if a layer was shed, but the core remained the same. And again, this doesn't seem like a coincidence. It's at this point that someone in the room says, if he's going to leave, he's not leaving empty-handed. He's leaving after he's checked everything. And no one argues, because it all feels like it's coming together. The return window as an opportunity, Jupiter as a switch, a dusty comet as background noise, and Atlas as an object that can manipulate momentum. The main question remains, one that's more important in this scenario than any number. Will we see him again? The honest answer is yes, it's possible, but not because of luck, but because the trajectory allows it. And if he returns, he will return in a year when no one expects him, in a week when the sky will be occupied by other events, and in a night when people will be sure that everything is already over.